Okay, part 2, the derivative of log base A of x. Now in this one, I want to recall the change of base formula. And change of base looks like this. And what base am I going to change this to? Well, what do I know the derivative of? Natural log of x, right? I know the derivative of ln x. That would be remembered easily, right? I hope. 1 over x. So if I can rewrite this to a natural log, then I'm home free. So let's see. Derivative of log base A of x can be rewritten as ln x over ln A. And that's your change of base formula. That's all that is. And I'm going to write this, or rewrite it. Notice everything can be rewritten. And that's what we're doing so much. We're manipulating and making it fit this pattern. So 1 over ln A times ln x. And 1 over ln A is just a constant. So if that's just a constant, and I know the derivative of ln x, what do I get? 1 over ln A times 1 over x. That's it. Alright, so let's see. It looks like this. The derivative of log base A of x is equal to 1 over ln A x. And what if it's a little more complicated and it's log base A of u? Then I have to apply the chain rule. And I get 1 over ln A x times, u prime. So this, I can't erase on this. This is a u. Sorry. Alright, let's look at some examples. Here's an equation. Y equals log cosine x. And you're asked to find the derivative. And so what do I do? Well, I can have that formula memorized, right? Derivative of log base A of u. I can write it like this, u prime all over ln A times u. So if I have the formula memorized, then it doesn't get much easier. I know that cosine x is going to be my u, so what's u prime? Negative sine x. Log, no base written, I understand that to be 10, so that's my a value. So ln 10 times u, which is cosine x. And I can rewrite this negative 1 over ln 10, and what's sine over cosine? Tangent x. And that's it. Let's do one more. Alright, y equals log base 5 the square root of x. So, as you know, we're going to do some rewrites here. X is to the 1/2 power. And then what can I do with that power? I can write it as a scale factor. So now I have 1/2, just the constant, u prime, well, it's just 1, over ln A ln 5 times u. Okay, and you can just simplify this to be 1 over 2 ln 5 times x. Can I write that ln 25? Yeah, I can do that too. And that's it. All right, I lied. I want to do one more because it's just a technique. And the equation that I'm asked to derive looks like this, x to the x. So I don't have an a to the x scenario. But what I do need to do is kind of release that exponent out of there. And how do I do that? Take the ln of both sides. And when I do that, I get ln y is equal to x times ln x. And now I still, that's just a rewrite. I'm asked to find the derivative, so I've got to take the derivative of both sides. And when I take the derivative of ln y in terms of x, so I got the chain rule, so I have derivative of ln y is equal to 1 over y times y prime. And now I have a product rule. First times derivative of the second plus the second times derivative of the first. And now it's a matter of manipulate, get y prime alone, simplify, all that good stuff. So on the right-hand side here, this cancels out to be 1 plus ln x times, well, y, get that out of the left side, multiply both sides by y, and I have this. Well, I want the derivative in terms of x, so let's swap out y. What did we say y was? Well, in the very beginning, y is equal to x to the x. So y prime is equal to x to the x times 1 plus ln x. All right, just another technique in finding the derivative of these fun exponential equations. All right, guys, go Patriots. See you on Monday.